Hello students, in this video we are going to see about Laplace transform of division. Okay, the statement is in every theorem we see that if L of f of t is f bar of s, then this is common in every theorem. Then here division by t, f of t by t is integral s to infinity f bar of s ds. Here f bar of s is the Laplace transform of f of t. So f of t, just here we ignore the division by t. Just we ignore the division by t. Okay. So see here, and we remember Laplace transform multiplication by t is the derivative. Laplace transform division by t is integration. So remember these two. So Laplace transform multiplication by t is derivative. Laplace transform division by t is integrations. Okay. Now, in the previous video, we have seen multiplication by t. Single t we derivate one time. T square we derivate two times. Like this. Here, division by t we integrate only one time. Integral s to infinity. The limits. Remember the limits. F bar of s ds. If it is divisible by t square, we have to integrate double times, double integral. So like this here, we shall see here, t square. So f of t by t square is double integral, s to infinity and s to infinity ds. So f bar of s. So we integrate f bar of s two times. If it is division by t power n, we get n times the integration. But mostly we get only division by t. Division by t. Rare cases we get t square. In exams, mostly we get division by t only. And rare cases we get t square. And t cube onwards impossible. I've never seen a question paper with the t cube, division by t cube. So rare cases t square. Mostly you get only division by t. Okay, but I explain t and t square also. Okay, in this first problem, we shall see find the Laplace transform of sine t by t. Here see the division by t. As in the previous theorems, just in first shifting theorem, we just ignored e power at, and multiplication by t, we ignored multiplication by t. Here, division by t. So we just ignore this and take only sine t as f of t, sine t as f of t, and find its Laplace transform. That is L of f of t. Sine t Laplace transform, direct definition 1 by s square plus 1 square. That is s square plus 1. That is, we take it as f bar. Now, division by t, we have to integrate f bar of s one time. Okay. F of t by t is what? Integral by this present theorem. Integral s to infinity f bar of s ds. What is f bar of s? 1 by s square plus 1. Now tell me what is the integration of 1 by s square plus 1 is nothing but tan inverse s. Tan inverse s. From the limits s to infinity. So upper limit we substitute infinity. So tan inverse infinity. Lower limit s in the place of s itself. So we get tan inverse s. So what is the value of tan inverse infinity is pi by 2. Pi by 2 minus tan inverse s. Pi by 2 minus tan inverse s is nothing but cot inverse s. This is optional. We can leave here. The exams we can leave here. So cot inverse s is optional. You can write or ignore. Okay. And next here, let us see the next problem. Find the Laplace transform of e power minus at minus bt by t. Here also we just ignore division by t and we take only the numerator, that e power minus t, e power minus e power minus bt as f of t. We find the Laplace transform of this one only. Okay, what is this Laplace transform of this one? We apply linear property. What's by linear property? We get L of e power minus at minus L of e power minus bt. So we divide these two functions separately. We find the Laplace transform. Now, e power minus at Laplace transform is 1 by s plus a, direct formula, and e power minus bt is 1 by s plus b. Okay, now the Laplace transform, we got it as 1 by s plus a minus 1 by s plus b. So that is only the numerator. So now division by t, we have to integrate this one. We have to integrate this one. So by the present theorem, division by t is nothing but integral s to infinity f bar of s. F bar of s is 1 by s plus a ds minus 1 by s plus b ds. Individually, we do the integration. Okay. What is 1 by s plus a is nothing but log of s plus a minus log of s plus b. So here steps are not there. I'll write here. Okay, integral. So here Laplace transform of e power minus at minus e power minus bt by t is nothing but integral s to infinity. Integral s to infinity f bar of s ds. Okay. Here what is f bar of s? What we got in f bar of s? 1 by s plus a minus 1 by s plus b. So same thing we get integral s to infinity 1 by s plus a minus 1 by s plus b whole ds. Okay. Here separately integrated. Here separately integrated. So that's the steps missed here. Okay. Now so separately 1 by s plus a integration minus 1 by s plus b integration here. Okay. So the integration is nothing but here I'll write the middle one. So 1 by s plus a integration is log s plus a and next minus 1 by s plus b integration is log s plus b. What is log a minus log b? Log a by b. That is log s plus a by s plus b. So that's what we got here. Log s plus a by s plus b. So two steps are not there in this PDF file. Okay. And next, the limits are s to infinity. So here, if we substitute infinity directly, the upper limit and infinity directly here in the place of s, log infinity plus a, log infinity by log infinity, we get infinity by infinity, improper form. So for that one, what do we do? So to avoid that improper form, take s common here in the numerator as well as s common in the denominator. Okay. If you take s common, not out of log, inside log only. Okay. S common. If you take s common, we get 1 plus a by s like this. 1 plus a by s. Denominator also after taking s common, 1 plus b by s. 1 plus b by s. So that s will get cancelled and what will be left? And 1 plus a by s and 1 plus b by s. Now, if we directly substitute the upper limit infinity here, we won't get infinity because a by infinity, something by infinity is 0. Okay. And here also b by infinity, something by infinity is also 0. Okay. And next, if we substitute upper limit, we get like this. And lower limit as it is, we get it. In the place of s itself. So we get this one. Okay. And next, so here in this case, log 1 plus 0 by 1 plus 0. Nothing but log 1. What is log 1 value? 0 minus. Here same thing, we get into the actual form that is s plus a by s plus b form. Log s plus a by s plus b. Again taking 1 by s common and we get the same form like this. So what is minus of log s plus a by s plus b? Reciprocal minus. We can remove minus and make reciprocal. That is log s plus b by s plus a. So this is the first problem we have seen and two problems we have seen till now. And let us see the third problem. Find Laplace transform of sine 3t cos t by t. Here also same thing, we ignore division by t and take only sine 3t cos t as f of t, and we first find the Laplace transform of f of t, that is f bar of s. Then we integrate. Division by t is nothing but integration. Okay. Sine a cos b as it is, as we have seen the previous problems, previous videos. Sine a cos b, sine a plus b plus sine a minus b. A plus b, what is a plus b? 3t plus t is 4t. 3t minus t is 2t. That is 1 by 2 into sine a plus b plus sine a minus b. So we get like this. So after division, we can do the Laplace transform directly. 1 by 2 outside as it is. And Laplace transform of sine 4t. Sine 8 is a by s square plus a square. That is 4 by s square plus 4 square. That is 16. Sine 2t is 2 by s square plus 2 square. That is 4. So we got a Laplace transform. So say just multiply by 1 by 2. So 4 by 2 is 2 and 2 by 2 is 1. So the denominator sign s square plus 16 and s square plus 4. Keep it as it is. This is f bar of s actually. We have to integrate division by t. We have to integrate this f bar of s. The integral s to infinity f bar of s, 2 by s square plus 16 plus 1 by s square plus 16 into ds. ds is missing here, so you can write ds here. Okay, so now here s square plus 16. How do we integrate this one? So which is the, so we have taken 2 common, we are separately 1 by 2 here, something missing here actually. I'll tell you, this is not 1 by 2, something missing here. I'll explain here. So integral s to infinity, here what do we get? 2 by s square plus 16 ds separately plus integral s to infinity 1 by s square plus 4 ds separately. Here ds is missing, left, right. And here 2 outside. And what is integral 1 by s square plus a square ds is 1 by a tan inverse s by a. 1 by a tan inverse s by a. Like this 1 by a. Here we take a square. What is a square? Nothing but 4. 4 square here. So 1 by 4 tan inverse s by 4. And here also plus. Here a square. What is a square? 2 square. Here a will be 2. Okay. So that is 1 by 2 tan inverse s by 2. Tan inverse s by 2. So here 2 by 4 is 1 by 2. So that's why we got here 1 by 2. 1 by 2 tan inverse s by 4 from s to infinity. And here also 1 by 2. We get 1 by 2 here. 1 by 2 have taken common. And tan inverse s by 2 from s to infinity. Something missing here, but the answer is correct here. So you can see here, easily we can understand. And next here, 1 by 2 anyway is common. And tan inverse s by 4, first one. Here tan inverse s by 4. So here I'll write here. So that is from s to infinity. So here I'm taking 1 by 2 common. And we get tan inverse s by 4 plus tan inverse s by 2. In both the places, in both terms, we substitute first here s by 4. This is s by 2. Okay. And next tan inverse. In the place of s, if we put infinity, okay, 0 to infinity, s to infinity, sorry, s to infinity. Upper limit infinity, what do we get? 1 by 2 into tan inverse infinity minus tan inverse infinity. Here actually minus, it's not minus, plus. Okay. So, okay. Here what happened? For the first term, upper limit minus lower limit. What is upper limit? Infinity. Tan inverse infinity minus tan inverse s by 4 as it is. And plus, next, in the second term, upper limit is tan inverse infinity minus tan inverse s by 2. Tan infinity minus tan inverse s by 2. What is tan inverse infinity is pi by 2. Tan inverse infinity is pi by 2. Tan inverse infinity is pi by 2. The remaining terms as it is. Okay. And next, what is tan in pi by 2 minus tan inverse is nothing but cot inverse. Here also pi by 2 minus tan inverse is nothing but cot inverse. So we get the final answer as 1 by 2 cot inverse s by 4 and cos inverse s by. Okay. So next we shall see another problem. Fourth problem we shall see. Okay. What is the fourth problem? Find the Laplace transform of 1 minus e power 2t by t. As usual, we take 1 by t, ignore 1 by t and take 1 by e, 1 minus e power 2t as f of t. First, we shall find the Laplace transform of this one using linear property. First, L of 1 minus L of e power 2t. This is by direct function. L of 1, L of k is k by s, so L of 1 is 1 by s. E power 8 is 1 by s minus a. So a is 2, 1 by s minus 2. Okay. So now this is f bar of s. Now division by t. We get integral s to infinity ds is missing here also, and f bar of s ds. What is f bar of s? 1 by s minus 1 by s minus 2 integration. Okay. And what is 1 by s integration? Here also something missing here. The steps, some steps missing. So here integral of that one is log s minus 1 by s integration is 1 by s. So 1 by s integration is log s, and 1 by s minus 2 integration is minus log s minus 2 from s to infinity. Log a minus log b is log a by, that is s by s minus 2 from s to infinity. S to infinity. Okay. So like this we got it. Log s by s minus 2 from s to infinity. And here also same thing as in we have seen in the previous problem, sir. In the place of s, if we substitute s, we get infinity by infinity in proper form. So that's why keep as s in numerator as it is and take s common in the denominator. So if you take s common, so we get 1 minus 2 by s. 1 minus 2 by s in the denominator. Numerator is as it is, and denominator we have taken s common. So these two s will be cancelled, and we get only 1 by 1 minus 2 by s. Now if I substitute infinity here, we won't get any problem because 2 by infinity is 0. So 1 by 1 minus 0. Okay. 1 by 1 minus 0 is 1. 1 by 1. Log 1. Here something missing. It's not correct actually. 1 by 1 minus 0 is log 1. So log 1 is 0. Anyway, we get it. And the lower term, if we substitute, we get as it is s. 1 by 1 minus. So here I'll write here. It's missing actually. After taking s common, we get 1 by 1 minus 2 by s from s to infinity. Now if we substitute infinity, we get log 1 by 1 minus 0 minus log as it is. I'm writing in the as a previous form, that is s by s minus 2 form. We can get into the previous form. So as it is form, this form, because s for s there is no problem. Here we get log 1. Log 1 by 1 minus 0 is log 1 minus log s by s minus 2. So log 1 anyway 0, 0 minus this one. So we can avoid minus, and reciprocal of this one is s minus 2 by s. S minus 2 by s. So we get like this. So the answer is log, actually have written, we can also write like this. Log s minus 2 by s. So we can write it. That's the answer of the previous fourth problem. And let us move to the fifth problem. And till now we have seen up to fourth problem. Division by t only. Mostly we get t only in exams. Rare cases we get t squared. And I told you t cube t power 4 onwards, it is impossible. Let us see a problem on division by t square. Only one problem. Sixth problem again, division by t. That I think that's the last problem. Later we can see Laplace transform of derivatives in the next video. So let us see two more problems in this video. So here division by t square. Division by t square we have to integrate two times. First of all, we ignore 1 by t square and take only numerator, that is 1 minus cos at as f of t, and we find f bar of s. How do you find f bar of s? By linear property L of 1 separated minus L of cos at. This is by direct formula. L of 1 is 1 by s, and cos at is s by s square plus a square. And here division by t square, actually it's mistakenly written t square. Otherwise we have to write only one integration here. So double integral. So we have remove second integral, write only single integral and division by t. Okay. So only one time integrate. We integrate only one time here. So 1 by s. Now integration of this one. 1 by s integration is log s from s to infinity, and s by s square plus a square integration is. So see here, to integrate this one, we apply this one. So suppose numerator is constant, we take it as a tan inverse. But the numerator s is there, we write in the form of f dash of s by f of s form. So we have a formula. So integral f dash of s by f of s ds is equals to log f of s. That is the denominator. Okay. So here in this case, denominator derivative if we get in the numerator, we can apply that formula. What's the denominator derivative? S square plus a square derivative is 2s plus 0. So 2s, we need 2s. To get 2s, divide and multiply by 2. 1 by 2 into 2s. So that we get in the form of f dash of s by f of s. Anyway, this term we have already seen. So 1 by 2 as is, and it is of the form f dash of s by f of s form. Okay. And what is f dash of s f of s form? Log s square plus a square. Log s square plus a square. And now from s to infinity. Okay. And next we apply, so log s minus log s square plus a square. Where is 1 by 2? It's missing actually. Here somewhat mistaken. So 1 by 2 means here we have to write 1 by 2. Here 1 by 2 is missing. Next step, it is correct. So few steps missing. I'll write here. Okay. So here, since it is a double integral, single integration we have already done. And log s minus 1 by 2 log s square plus a square. So from s to infinity ds, double times integration, so single term is over. And next here, log a minus log b. Here 1 by 2, just I'll remove this 1 by 2 and write it as integral s to infinity log s as is minus log s square plus a square whole power 1 by 2. Whole power 1 by 2. Instead of writing that one whole power 1 by 2, I'll write square root of this one. From s to infinity ds. So log a minus log b, integral s to infinity, log a minus log b is log s by s square plus a square under square root from s to infinity. So these steps missing here, directly we got log s by s square plus a square under square root from s to infinity. This is what 2-3 steps missing here. Okay, anyway. And now here, now I'll explain here directly. Now, in the place of s, again, if we substitute infinity, we get infinity. Infinity by infinity, improper form. So for that one, as usual, keep s in the numerator as it is and take s square out of square root. S square out of square root is nothing but just s. We get s 1 plus a square by s square. 1 plus a square by s square. This s and s gets cancelled. Now we can substitute infinity here. So we get here also same problem, same mistaken. Okay, here I'll substitute. Now integral s to infinity log, yeah, first in the place of s we substitute infinity. So what do you get? 1 by square root of 1 plus 0. A square by infinity is something by infinity is 0. So we get in square root also here. And next minus upper limit minus lower limit. For the lower limit, we can write as it is s by s square plus a square under square root as it is. We can write whole into ds. This what we get here log 1. This is nothing but integral s to infinity log 1 minus log s by s square plus a square under square root ds. So log 1 is 0, 0 minus. Instead of minus, we can do removing minus, we can do the reciprocal of this fraction. That is s square plus a square under square root by s ds. By s ds. That's what we got here directly. Log square root of s square plus a square by s ds. Now we have done only one time integration till now. One time integration till now. So that is if it is only 1 by, so 1 minus cos st, cos at by t, this will be the answer. Division only by t, this will be the answer without the integration. Okay. Now, since it is division by t square, we have to integrate again. How do we integrate log? by taking log as u and 1 as v. We take 1. So here I'll write it again. To integrate this one, we take log this one as 1 second into 1 ds. Okay, this we take it as u, this we take it as v. Okay, uv form. What is uv form? Here I'll write uv form. Integral uv is nothing but u into v integration minus integral u dash into v integration whole integration. Okay, like this. U is log, v is 1. Okay, u is log, v is 1. U, what is u? Here, what do we get? Log s square plus a square under square root by s into v integration, that is 1 integration minus integral. What is 1 integration? We got it as s. Directly it has written minus integral s to infinity. Okay, integral s to infinity. Derivative of this one. What's the derivative of this one? 1 by s square plus a square under square root by s into derivative of this one. Okay, so 1 by 1 plus, so it's written as it is like this, as in the previous form. What is the previous form? Taking s common. Taking s common and cancelling, what you get? 1 plus a square by s square under square root, so that the derivative will be easy. Now, 1 by square root of 1 plus a square by s square into derivative of this one. What's the derivative of this one? Okay, here square root is not there. They have taken outside, because if we get square root, we get problem. Okay. Now I'll explain. Just wait. So if we get square root, the integration derivative will be very hard. That's why we have to take 1 by 2 outside. So I'll explain here. Just wait. Okay. Now log this one, they can be written as what? Integral h to infinity log square root. I'm taking square root to completely s square plus a square by s square total square root. Total square root ds. So s square, s also I'm taking under square root. So we get s square. The cancelling it, we get integral h to infinity log 1 plus a square by s square. Square root. Square root will become 1 by 2 here ds. Okay. Here bracket, and totally we take it as u into 1 as v ds. So now 1 by 2 anyway outside, and integration the log 1 plus a square by s square into 1 integration 1, nothing but this is u, this is v. Okay, and next ds minus integral u dash. What is u dash? Log derivative. What's the log derivative? 1 by 1 plus a square by s square into 1 plus a square by s square derivative. One derivative anyway 0, and a square by s square derivative is a square into 1 by s square derivative minus 2 by s cube. 1 by s square derivative is minus 2 by s square s cube into ds. So one integration. Again, here we get v integration is also there now. V integration. Just now we done only u dash and integration of v. Integration of 1 ds. Second. No. ds whole into ds. Okay. This what we got. Log 1 plus a square by s square as it is here. Log 1 plus a square by s square 1 by 2 outside into 1 integration is s minus infinity. This is the derivative. Just now we done. Into one integration is s ds. S ds. So yes, I'm taking the starting and log 1 plus a square by s square plus here what is a common thing we take it as now minus 2a square. Minus 2a square we can take it outside. So minus of minus plus 2a square. And this is as it is 1 by 1 plus a square by s square into here what is left here? This s and s cube after cancelling get 1 by s square ds. 1 by s square ds. Here also take LCM. So what do we get? S square plus a square by s square. So that this s square can be cancelled. So in the next step we shall see it. The first term is as it is, no change. Plus 2a square is also as it is. And here the LCM we get s square plus a square by s square. That division by s square we come to the numerator here. S square by s square plus a square into 1 by s square as it is. So that this s square and s square will be cancelled. What will be left? 1 by s square plus a square is left. So what is left? 1 by s square plus a square. What is integration of 1 by s square plus a square? Nothing but 1 by a. In the previous problem we have seen 1 by a tan inverse tan inverse s by a. The first term is as it is till now. Okay. Okay. And next here we got a square and by a. So nothing but a. 2a will be left. Okay. Tan inverse s by a as it is. This term first term as it is. Now we have to apply s to infinity. S to infinity. Directly we can substitute here. If we substitute here in the place of s, infinity, no problem will get because infinity into 1 plus a square by infinity. That is 1 by infinity 0. We get log 1. What is log 1? 0. 0 into infinity. What is 0 infinity? 0. Here the term is 0 minus upper limit. Upper limit minus lower limit. What's the lower limit? S. That is S as it is. S into log. So here I'll explain. In the place of S, if we substitute. Okay. In the place of S, if we substitute infinity into log, in second, 1 plus a square by s square. That is 1 plus a square by infinity. What is a square by infinity? Something by infinity is 0. Okay. Infinity into log 1. 1 plus 0. Okay. So 1. Log 1 is 0. Infinity into 0 is 0. So the first term is 0. Minus lower limit as it is we get. S into log 1 plus a square by s square is as it is. Next. Here if we substitute infinity here, tan inverse infinity is pi by 2. Tan inverse s in the place of s, s itself. Pi by 2 minus tan inverse is cot inverse. Okay. Cot inverse s by 2. Now here 1 by 2 I'm taking inside. So minus s by 2 log 1 plus a square by s square as it is. And 1 by 2 multiplied by 2a, we get a. A into cot inverse s by a. So this is the final answer. So rare cases we get division by t square. Mostly we get only division by t. Okay. T cube problems impossible. T cube, t power 4 problems impossible. Okay. Let us see next problem. Find the Laplace transform of e power 2t into sin t by t. As usual, we ignore 1 by t and we take only e power 2t sin t as f of t. And we find only the Laplace transform of e power 2t into sin t first. Okay. Before that, first we find sin t Laplace transform. What is sin t Laplace transform? Directly by using formula 1 by s square plus 1 square. 1 square is 1. And e power 2t multiplied by e power 2t, we apply which theorem? First shifting theorem. In the first shifting theorem, we change shift s to s minus a. What is here? 2. S minus 2. So in the place of s, put s minus 2. So we get s minus 2 whole square plus 1. Okay. What is s minus 2 whole square? S square minus 4s plus 4. So s square plus 4 minus 4s plus 4. So here we get s square minus 4s and 4 plus 1 is actually here 5. It's mistake. Okay. 5. And next Division by t, we get integral s to infinity 1 by s square minus 4s plus 5 ds. Here it is actually plus 5. Okay. Now we can see here, we can leave the s form as it is, 1 by s minus 2 whole square plus 1 as it is here. 1 by s minus 2 whole square plus 1 as it is. Okay. So that it is of the form 1 by x square minus 1, where x is equal to s minus 2. What is the integration of tan inverse here? What we got? Integral s to infinity tan inverse, sorry, it's not tan inverse, 1 by s minus 2 whole square plus 1 ds. That is, what is the integration of 1 by x square plus 1 dx is tan inverse x. In the place of x, we write s minus 2. So we get what? Tan inverse s minus 2. Tan inverse s minus 2. That's what we call tan inverse s minus 2 from s to infinity. As usual, we apply upper limit infinity here. Tan inverse infinity is pi by 2. And the lower limit s as it is, we get tan inverse s minus 2 as it is. So pi by 2 minus tan inverse is cot inverse. So this is about multiplication, division by t. Okay. In the next class, we shall see the Laplace transform of derivatives. So this is, in this video, we have learned division by t.